So, I think we are live now. I welcome to this Zürich Clojure user group session about Babashka. And before we start, I just want to say that it's the first time that we are having a hybrid setup. We are in person here in Zurich, and we are at the same time streaming live on YouTube. I hope that everyone can listen and the setup is working as intended. Before we start, I just want also to mention our sponsors. First sponsor for your speaker and sponsoring the drinks after the meetup and the location is Smith, and other sponsor is 200 OK, which is a company which supports us, that supports the meetup membership. So, and now without further ado, let's start to talk about Babashka. And so what is Babashka? Babashka is a Clojure environment that allows you to program, but it's not based. It's based on the GVM, but it's a bit special, and we will look at why. And the point of Babashka, the usage that it's targeting for is to do fast scripts, right? If you do a little script and you start with Clojure, it takes always a long time to start up. The GVM is not really made for interaction use, but Babashka is made for that. And so how does it work, right? Then just let's go to the terminal, and here I can type bb, and I can actually evaluate 1 plus 2. Let's make this bigger. I think it's better like that. So, and what is this? What is this program BB? And if I look, I'm exactly at the folder where the file, where the BB executable is stored, and as you can see, it is an executable. It's not a shell script that would call the GVM and Clojure to start. It's really an executable. And to tell you, before we dive more into how to use Babashka, I just want to show you the two technologies, that makes it possible. So the first is, before I go on, I of course forgot to tell that Babashka is the brainchild of Michiel Borkent, also known as Borkdude. He's doing a lot of Clojure tools, and he's in particular Babashka, but also clj-kondo to do linting and other stuff. So here is his homepage. You can find, as you can see, Babashka itself is a Clojure program. It's all Clojure, and yet we saw before that there were apparently no GVM. And this works thanks to GraalVM. And so GraalVM is a product by Oracle, which is a just-in-time compiler that sits on top of the normal Java VM. And we used to just-in-time compiling from the standard hotspot. But what is special about GraalVM is, first, it's completely made in Java, and second, it has the ability to do this just-in-time compiling ahead of time and to compile native images. And this is what Babashka uses to compile itself, to have this native executable. And this comes with advantages and disadvantages. The main advantage is speed, right? Because you don't have any, so the GVM disappears somehow, and there is no class loading happening, and so everything starts instantly. But the big disadvantage is that it's no more as dynamic as the GVM is, right? With the GVM, you can load classes dynamically, and with GraalVM, it's not possible anymore. And so you can imagine it's a challenge to compile a Clojure program with GraalVM, with the native image tool, because the the language is so dynamic, right? And so this is the first thing. And what GraalVM does not allow is to create classes on the fly and to load them on the file, right? So, but we just saw, right, Babashka is able to evaluate expression, and it can actually also, you know, evaluates. I hope it's working. Oops, I made a mistake, of course. Right, it can also, you know, create function on the fly and do all this stuff. So it seems to be a contradiction with, so is it a Clojure? We would expect maybe there is a Clojure compiler here in the background, but this is not possible because the Clojure compiler will create class on the fly and load them. So to do this kind of scripting, you need an alternative. And the alternative is what Michiel also did, which is called the small Clojure interpreter, which is an interpreter written in Clojure itself for a subset, but a significant subset of Clojure. And I happen to have a project here with it, so we can just have a look at this. So I have here a Clojure REPL with loaded with the small Clojure interpreter, and when I evaluate the string, you can see it gets evaluated. And the point is, the small Clojure interpreter itself let itself be compiled to a native image, and this is actually the point, to make it run fast. And why would you want to use this just as a side? Why would you want to use this as a library inside another Clojure program? Well, maybe you want to load and execute some code. You don't want to execute this with eval, and because it's very dangerous, right? You could do anything. And the small Clojure interpreter actually does not allow you to use out of the box all the functions that are available to Clojure, only a subset. And there is kind of a sandboxing going on. And there are many projects using SCI as the small Clojure interpreter as a Clojure interpreter to allow extension and coding. And one example is Mali, which is a schema validation library by Metosyn. And here, if I say, let's first begin with the schema, which is I think you can even, it's okay. And you can see this is valid, but now I would love to have a map which has a bit more property. I would love to make sure that X is bigger than Y. And so I could actually say that I expect a map, but I expect a bit more. I expect also a predicate to be respected, to be fulfilled. Oops. And you can see now it's no more valid. And now it's valid because X is bigger than Y. And the point is, by using the small Clojure interpreter, you can actually serialize your schema and put them on a database and things like that, and it will execute the Clojure code via this small Clojure interpreter and not via the Clojure eval. Perfect. So now that we saw that, I would like to illustrate Babashka itself. And for this, you find already a lot of very, very good videos by Michiel Borkent himself and others. And so I will try now to show you within a kind of real project that how would you use it in a real use case. Right. And so for this, I have written a very small project, which is a very small web app that actually has some roots like hello or token, and then gives it could be a very sophisticated web app, but now it's just simple in one namespace. And typically when you have this kind of project, you have a host of scripts to build it, to test it, to start locally, and all of this. And here, as you can see, I have already a bit of scripts. I have a script to test that use Clojure, the Clojure CLI tool to start the tests. I have another script to build a Docker image using a build script from Clojure tool build, right, with some libraries. And as you can see, the script goes in 2 steps. First, it verifies, so verifying, you see what it does, and then it builds the Docker, and verify is just calling first linting and then test. This kind of bash script we all wrote for our projects. I want to illustrate to you how you can replace it or replace them with Babashka. So first of all, let's start this little server just so that you can see what it does. And so here, this I don't need anymore. I will also just make this bigger. Actually, oops, all of them. Because it's already done. It's a bit better. So we have this script which is called start server. So let's start it. And what this start server does is just it just starts the program with Clojure tooling. So it has started, as we can see here, on port 8080, and let's curl to see whether it's working. Yeah, it's working fine, right? And since it's a Clojure program, actually it's quite cool. We can have also Eden. Perfect. And actually, this is a good example to show you what you can do with Babashka. Because Babashka is not only writing script, it's also writing small one-liner like you would do with sed or this kind of tool when you program bash, right? And so I can actually pipe, and you can see it's the dynamic variable input is just the input. Actually, it's a bit more than that. When you use the -e flag, Babashka expects, that's the word, expects Eden string and will actually parse it. Right, so I can actually here, because input is already a parsed Eden, which means it's already this map with the keyword greetings and the string hello. I can actually thank you. I can actually, write out of the box. I can I can evaluate and extract the key. So let's go back to this one. Now let's say I don't have any more the Eden. It's a standard web service that you need to call during whatever script that you are building, and it gives out JSON. So as you can see, when I just use input like this, it will fail because the JSON file is not an Eden file. And there is a flag, a set of flags that we can tell Babashka not to interpret the string as Eden, but just to interpret line by line the input from the standard input with -e. And so with -e, I get this sequence of string, and the first is a JSON file. So we can actually do stuff here also with JSON, because Babashka comes with batteries included. In particular, so here I just extract the first, I'm just interested in the string itself. In particular, we can, there is Cheshire, which is included, and it's available in the user namespace under the JSON alias, and I can actually parse JSON. Oops, I forgot parentheses. And as you can see, I could parse. Now I prefer to have keys, then string as keys, and then I can do greetings, and again extract the whole thing. So as you can see, this kind of thing, this kind of stuff you can do with tools like JQ, or you can do certainly with Python. I did stuff like that. What is cool about Babashka first is it's Clojure, but of course there is also much more stuff than in JQ. Right? JQ is really specialized to parse and to go inside a JSON file, but Babashka you can actually do a lot much more. It's you have a whole set of libraries which are included with it directly inside the executable. So there is this, we have a HTTP client, we have an HTTP server, we have file manipulation, and so on and so on. Good, and now I said, well, we have HTTP client, so actually we should be able to do this curl call from inside, right? So let's try to do that. So first, let me copy that and just execute the string. So that is the string. This is what we want to call. And I can actually, there is a namespace called curl that with underlying use curl actually, that expose curl, which is a C program, but expose it as a set of Clojure functions. And here I can do curl get, and as you can see, I get the response back, right? The full response as a map as we are used to, even if it's curl in the background. So what actually I would love to do is to have an Eden, because we know that Eden is available, right? So let's fetch it. So we add these headers and now we can see that by adding the accept header, I get an Eden value. Now I can extract the body. I can actually parse it. Read, actually it's called. Right, and I can actually also extract the greetings key. And as you can see, this one-liner is starting to get a bit long, and it's time to think about how we could write this in a file. And actually, you can just create a file. Let's go to IntelliJ and create a file here. I will actually create inside script. Oh, let's do this. Let's add. It's just for cosmetics for IntelliJ that it does not complain. So we just add the script folder. So let's add here a file which we called curl test. It's a Clojure file, and actually I can copy this one-liner inside. And now I can call Babashka with the script as an argument, and it just loads it and runs it. But we can do a bit better than that, because with Bash we used to be able to make such scripts executable and then run them, and Babashka can do that too. So with a standard shebang. And now I have to make it executable. And now you can see that I can call it directly. So you can actually write some scripts and then have them be executable, some Clojure script, and it's just one file. There is nothing more to it. Actually, it's not the way it's recommended to write this kind of scripts, because when you run these scripts, you are in the namespace user, and Babashka loads for us certain namespaces. But if you would want to lint this kind of files, then it would be an error, because we don't know from where these things are coming, and so it's recommended to actually write a namespace inside and use a normal namespace. So let's just do that. It's a styling issue, and now of course if I do this, I'm no more in the user namespace, so all of these things is no more loaded. I have to load it myself, so I have to require Babashka curl as curl and Clojure Eden as Eden, and now it should work again. Yeah, it's fine. So here I can now, because we don't have any more one-liner, I can actually format a bit, that it's a bit better to read. Right. Yeah, it works, still works, perfect. And you are actually not, so Babashka includes a lot of libraries, as I said. But you are actually not completely, something before we start about that is that Babashka comes, I think it's really cool, this you can never do with bash scripts. I can mark here in IntelliJ as a Babashka's file, and I can actually start a Babashka REPL, right? Because there is a REPL for Babashka, and I can load this, and I can actually evaluate expressions of my scripts in a REPL. So I think I never saw before, at least I don't know any bash REPL server that allows you to test a little bit of your scripts at the REPL and develop them. So it's quite awesome. By the way, if you just run Babashka without arguments, it will start the REPL, and then you can start typing stuff. Great. Then, yes, you can have much more than the standard libraries. You can add actually any Clojure libraries to Babashka at runtime. It will load the library, but of course the caveat is that these libraries must be pure Clojure libraries, because you cannot load a Java class. So you cannot add a jar to the class path, right? You can just add pure Clojure libraries, but by no means it's by no means so terrible, because I want to give you an example. So to do that, of course, is where you declare these kind of dependencies, and for this you need a file, and the file must be called bb.eden, and it's a configuration file for Babashka, and it will load the file from the directory where it's called and load inside the dependencies. So let's actually go and grab, do I have it here? No, of course. So let's, one library which is available is Spectre, which is extremely powerful library that will be presented later this year. And I just want to show you that you can actually use Spectre inside the REPL of inside Babashka, which is quite something. I have to go to the solution. I'm sorry, because I don't know the namespace of by heart. All right, let's restart that. So instead of doing greetings, I could actually use Spectre. Oops. To do just that. So if I go and it works, right? So I can actually use Spectre, which is a quite powerful library. If you never use it, I strongly encourage you. So by no means you are, of course you are limited, but still you can use really powerful tools. Now with Spectre you can do tree transformation and everything crazy, so you can even do this without starting a proper GVM. That's quite cool. Perfect. Now let's, now that we saw scripts, one-liners and scripts, I'd like to go to the next step, and it's about replacing those scripts that are here, right? The script that we use to build and test a project, right? Let's first run the test script. So the test script use the Clojure tooling and just run your tests with a test runner. And we would like to use Babashka for that. And actually, I don't want to write just a script like this. I would really love to have something like we find with RPM, when you can define task inside the dependency file, or make file when you can define task to perform. And actually, Babashka can do that. And in the configuration file, you can ask the tasks key, and here you can define tasks. So let's first define test. And test is, as we can see here, is just about calling the Clojure tooling with these profiles, right? And the Babashka has an API for us for tests with the Clojure function, which actually will close the tooling, and I just have to give the arguments as a string. And now if I do bb test, it will actually call Clojure and run the tests. As you can see, the test has been run. Right, that's quite cool. If I do Babashka tasks, it will actually show me which tasks are available. So now we can imagine that after a while I will have like thousands of tasks, or maybe not 1,000, but 20 or 30. And so it would be great to write some documentation and what all these tasks are about. And here, instead of writing directly an expression, I can use a map. And this maps allows me to write a little documentation that will appear when I ask Babashka to list all the scripts. So what I can do also is I can run shell scripts. Sometimes it's useful. I have this lint. It's a bit too complicated. I don't want to change it right now. It's it's a step-by-step approach. So let's run a shell. And here I have the shell function at disposal that allows me to give which shell command I want to run. And here I want to run scripts lint. And documentation lint the project. Runs the test lints the projects. Right, and if I look at the task, now I have both tasks at disposal, and I could do lint, and then it will run the shell scripts, and then it will do the linting. Now we saw that the verify was actually just doing one after the other, and let's just do that also here. And it's a point where you can define dependencies between tasks, because this is really actually you want to have verify depending on running test and lint. And for this, you just had actually verify itself is not even a proper task. You just say with the depends key on what it depends. And And now if I do tasks, you can see that verify is now here. And so when I do verify, it first does the test and then the linting. Yes, it was maybe too fast to see, but it did both. Awesome. Then, so it means that actually all of these tests and verify we don't need anymore. And now let's have a look at build Docker. So build Docker is about first verifying and then building the Docker image, right? And actually building the Docker, it's written like this because I never want to really build the Docker image without testing first. One of these ideas, like I would like to have everything at once. But sometimes it's useful to just do the building, right? Just to test if I'm testing the build scripts or something like that. And so the best would be to cut this in two parts. First there is a verify step, and then I would love to have just this step like as a internal private step that does not appear, or that it's clear for the user's perspective that of my project that it's not something which is meant to be called by itself. And I can do that by prefixing with a minus. And so if I do build Docker and the task is a Clojure task, oops, I can actually do this. And now if I do task, it does not appear in the list. Of course, I can still call it explicitly, but at least it has been clear from the beginning that it's meant to be private or to be internal and not to be called like this. So I just created this, and now we can actually have the real build Docker task. Which is about verifying and building the Docker. And now I can see it runs the test, it does the linting, and it creates the image. And so that is for tasks. I think it's really neat. I always wanted a kind of similar tooling to just do little stuff and write them in Clojure, and this is really perfect for that. You can run things in parallel. There is a lot of options there. You should go see the documentation, but really, the only thing you need to use that, to do that, is to have this bb hidden file, and then you are already this. Yeah. So finally, just as a little fun is well, you could write a lot. You could write a complex program with Babashka, right? You have almost all Clojure. And actually, I have here the very same server that I built in Babashka. And for this, I just need this. I just need a new task. And I say, well, this task should call the main function in the main, and it has these supplemental dependencies. This is a router. And now if I kill the other one, and oops, of course, this is demo effect. Oh, of course, I have here to say where scripts can be found, and they can be found in the scripts folder. and here server has started, and I can do my little one-liner again, right? And the script is just defining this route via this router and using HTTP kit to run the server, which is included in Babashka. And so, of course, you would not want to. The problem is with this Clojure with Babashka is it starts extremely fast, but it's an interpreter, right? Everything is interpreted. It will never compile to bytecode, and then it will never be jittered to machine code. So you would never gain the performance. You will never have the performance that you can have with a real Clojure. It's a real Clojure program, with a Clojure program running on the GVM, I mean. But for little things like a test server locally, I mean, why not? I mean, it seems to be really, it's really cool. That's it. So I'm already finished. It's a short one. So if you have questions, you can ask.
What's the runtime for this? So what's the runtime for this when you say that this is interpreted?
I did not understand.
What's the runtime for this?
Oh, so the runtime, yes. So the question is, what is the runtime for that? So the runtime is actually it's the small Clojure interpreter, which is this project, which is an interpreter of Clojure, of a subset of Clojure written in Clojure itself, and it's actually the point of the small Clojure interpreter is that it's amenable to native compilation with GraalVM. So at the end, Babashka, the tool itself, is a native. Is just one executable, like if you would compile with C, C++, or Rust, and it integrates this interpreter. And to actually compile a Clojure program for Graal, you have some, or a Java program for that matter, you have some restrictions of what you can do and what you cannot do. In particular, you cannot create new classes and load them. And therefore, for instance, protocols in the small Clojure interpreter are implemented via multi-method. Right? You don't gain the speed advantage of protocols on Babashka because you cannot just create on the, with protocols you can create on the fly. You can create a new type and load the class in the GVM. Here you cannot. So it's implemented using multi-method. So everything is not only it's interpreted, but it's also using features which are maybe slower from Clojure. And so at the end, you will have a slower runtime, but one that starts instantly. So I don't know where the two curves meet, right? From when you do a certain program, if you run it with Babashka or you run it with a GVM, there is a point where after a certain amount of time, where the Clojure variant will pay off for the starting time that you have. But for small interactive stuff like we just saw right now, it's really great to have this runtime environment.
Maybe serverless applications?
So there is a question about serverless application. Yes, I guess you can, because you can create, for instance, AWS Lambda, you can create your own runtime. So you create a Babashka runtime and run things. So I guess I think the AWS API runs without I'm not sure. I didn't check. I should have checked. But and so assuming that that you have, because actually at the end it's just HTTP call, right? The AWS API. So assuming that the Cognitec library works with Babashka, then you can actually write small lambdas that I would not write a lambda with Babashka that would serve 100,000 of connections or requests, but to do all the DevOps glue, right, on AWS. This is probably a good fit as well.
If it's run in the background where the speed is, it has to start quickly, but then it just does a few things and then it stops. It would good fit for this.
Yeah, exactly. So it's you saw the starting time. I did not show you, but it's really short.
When you talk about serverless, for example, HTTP server, you just thought, what's the footprint of that in terms of memory? Can you check?
No, I did not check. I did not check.
Can you just start it and check?
Yeah. I don't know how to check, to be honest. So here we started.
You just start and you stop in another batch and then you will see.
Yes.
You open.
Okay.
Okay, it's run inside the Docker, I guess.
No. It's not inside Docker. Let's go into activity. Because it does not use a lot, it seems. Maybe it's under BB. Yeah, it's here. So which one? I don't know. Because I have a REPL, so let me kill the REPL.
So do you
Yeah.
want to check the footprint?
Yeah,
Memory?
when you use it for serverless, for example.
So the memory it uses.
Because you said the HTTP kit is part.
Yes, you see, it's like 50 megabytes right now.
Okay. Yeah, that's reasonable. That's okay.
It's like 50. The executable itself of Babashka is like 73 megabyte and contains a whole set of libraries, so I can show you what it contains. So there is, the documentation is very good, and this is all that comes from Clojure, and these are additional libraries. So in particular you have Cheshire for JSON and the HTTP kit client and server,
Yeah, async as well. Core async.
and core async as well. Core async, there is a caveat there that the Go macro is not supported, and instead it will spawn a GVM thread, right? And it will replace all non-blocking stream operation with blocking stream operations. Right? Oh, it's even. Oh, whatever. There are, of course, much more to Babashka, but yeah. So there are pods, for instance, pods I did not talk about, which are like C program that you would like to call, and it's a small library that wraps via a certain protocol, so you can get values of those calls without yourself, starting a process and parsing the output and stuff like that. So these are. And actually, I don't know now what is the state. At the beginning, there were a few Java libraries included, because when you want a Java library, it has to be compiled in, right? You cannot add it as a jar after the fact. And I don't know now how much the developer is open to add new libraries. I guess your pet library probably not, or my pet library also not. But if there is an important Java library, or maybe there are instructions on how to create your own Babashka variant where you integrate more Java library. Because this has to be compiled in with Graal, so it's in the tool. The Java stuff is completely in the tool.
I have a question. What would be the trade-offs of using Clojure script and Node versus using Babashka?
That's a good question.
Can you repeat?
So the question is, what is the trade-off between using Clojure script with Node against Babashka? So actually there is a project called Plank, which is this Clojure script runtime, which is also in that you can also use to do one-liners and scripts. It does not start as fast as it's called Plank as Babashka. And I think if you time it, you will see a slight difference. It's not a real benchmark, but as you can see, and I mean the other trade-off that you have is that you have Node. It's not, because in Babashka it starts as a GVM project, which is like specialized. It's a special compilation of a GVM if you want. So you have all of the feature that comes from Java. So maybe you find this on Node. I don't know. And also you get all the libraries, also most of the libraries to run really on Babashka to add it, it has to be a pure Clojure library, and very often they are compatible with each other. I don't know. I'm not so familiar with ClojureScript development, so I cannot.
It was NVB. Did you know it was NVB?
So the question is about NVB. I don't know what NVB is.
It's called NVB, and it's basically a Node version of Babashka.
Node Babashka. Yes, there is one. I did not know.
Getting very meta.
Yes.
This is if you want to have node libraries. If you
Right.
really are into node libraries, then you can use Babashka with node libraries.
So you don't even have to choose anymore? Awesome. Thank you. So I didn't know about that. So it's great. So you can do you can do both.
I guess that answers the question.
Yes, you can do both. And maybe if you are generating HTML or using whatever libraries which comes from JavaScript, then of course you will want to use that. Awesome.
So you're replacing all your shell scripts with
So the answer is no. I'm not replacing all my shell script with these, but I'm certainly replacing all my little scripts just to start stuff off for a project. Like I showed you, the task thing. I think it's really, really useful for all of this small stuff. And then it's all in with BB, just all in one little package. This is really, really nice. And I think, I did write some stuff where, as soon as you want to do more, for me, very esoteric bash stuff, like looping over the children of a folder and doing something, right? Of course, you can do it in bash. What I do, when I do this in bash, I go to Stack Overflow and I copy paste, and I just don't understand exactly what's happening. Maybe, but not really. And then you have this very strange, with variables, where are they valid and stuff like that. And as soon as it reaches this complexity, and I have Babashka at disposal, then I would certainly use it, because you have included in this, there is a very useful FS library, which actually it's a wrapper around Java NIO path and files, the new IO for files. And it has a lot of very cool function to create directories, to loop over children, and so on and so forth. So as soon as you do something, or I have an example for one of my customer. I have very complex bash scripts that will look at a Maven Nexus repository, certain jar out there, and stuff like that. And this I do, and it's supposed to work, on old Linux and even on Solaris and stuff like that. And so I cannot use, I just have to use vget and write to temporary files, and then I pass them with Python and stuff like that. And it would be so much better with a tool like Babashka, because I would have just one script that really do these calls and parse the JSON and everything, instead of having a lot of pipes in my bash with 5 different tools. I have like batteries included for this kind of thing.
So that's the other question, how portable is it?
So Babashka itself, I think it's quite portable. I don't think it's run on Solaris, I don't know. But it certainly runs everywhere where GraalVM compiles. And so it runs on Windows, it runs on Linux, it runs on Mac. So I think they have a Docker image. And so it's you can do quite a lot. But of course, if you are in corporate, of course it's very difficult to bring those tools. You have other hurdles than having the platform which is compatible, is having the tool at all available, right? But if you have control, by all means use it. It's really good. So, is there any other questions? If not, then you have one? Yes.
Just one. do also some kind of runtime work, so invoke scripts, etc. And all for all OS specific stuff, we use the runtime wrapper of Java, which is A, portable, and B, quite fast, and it's a reliable solution. And for our control flow, as you said, for example, iterating or staff looping and JSON parsing whatsoever, we use normal JSON libraries. So we combine Java runtime,
Yes.
which you can check, but it's also quite good because we do a lot of LaTeX and GoScript stuff in our programs, calling this from or invoking this from Clojure. And so we just use runtime, which is available for 20 years now. Not in Clojure, because it's not Java, but in the Java. You know what I mean? It's class runtime.
Oh,
That's the runtime.
Yes.
So you
yes.
can do scripting as you want. Of course, you have some problems parsing all the results from this. But yeah, actually, it's not that hard to get error codes.
Yeah, I never used, so I cannot really comment. So, but
because there you can also forward and wait, and you can do all this.
so here you can do also all of this, right? Because I mean, you can in Babashka you can run stop threads and do everything, because it's at the end it's the environment that the native image tooling of GraalVM offers you, and it offers you all of these facilities as well, right? And what I really like is about this fast starting time, you know, that when you there, I think there are more than one use. So there is the use of I'm programming, I'm doing stuff, and I need to automate certain little step that I do, right? And for this is normally I would use Bash to do that. And I think with Babashka I don't need to write a collection of Bash script that calls each other, or I don't need to write a make file. I can write this bb Eden file, and I can do these small tasks. And then I think you have the more complicated stuff where, I mean, the larger your Babashka program becomes, the more you have the question, is it not worth writing directly in Clojure, right? I think there is a trade-off at some point, and I don't know exactly where it is because I did not use it enough.
Yeah. What I really see, where it kicks as we have large make files, and when I see your Eden file, I could imagine you can just write macros because Eden is just Clojure, it's just Clojure data structures. You build them, you generate them using Clojure code, because with make files you cannot just do it. It's too, the syntax is too brittle, and it's that would be cool.
Yeah. So, I have to say also very important, that's a very good point that you bring, that it's an Eden file. It is really an Eden file. And so here you cannot do certain Clojure shortcuts, right? For instance, the function shortcut with the hash does not work here because the Eden reader does not read those forms. So here is really, it's a pure Eden file. And then I can show you an example of that. I could do something like task is a Clojure expression. So let's do another one just to test. This is completely ad lib, so we'll see if it works. Let's do an addition and task, and it's about printing. Just first we do like this to see whether it works. Yeah, it works. But now I cannot do something like this, because this form is not Eden, it's Clojure, and it's not the same, and so it will fail because there is no dispatch macro here, as you can see. So this is really Eden. So if you want to generate those, you need to pay attention to make sure that you generate Eden, and it's not always an easy problem. easy. Yeah, it's not always an easy problem. Sometimes it can be hard to generate hidden due to some with tag literals and stuff like that. I know that it can be difficult. But you can, use write functions. So this is just. So inside this BB hidden, of course, you can generate scripts like this one, right? This is then, and you can call it from. If you want to generate code. Is there another question? So if not, I will close here. Again, thank you for attending tonight's session, and thank you also to the people which have been following us on YouTube, and we'll have another one in a month. So thank you everyone, and bye bye. No, there were no questions.